Yes, welcome to our online class. Today we shall be discussing the formation of differential equations. And we have some examples here we're going to treat together. First question here is y equals to ax plus a squared. We have number 2, y equals to a cos x plus b sin x. And the third one here is y equals to a exponential to the power of 3x plus b exponential to the power of x. So let's get started. Solution. Now, number 1, we have y equals ax plus a squared. When you are treating the formation of differential equations, our aim is to eliminate the constant. So we are going to eliminate constant a. So we have a here, we have a squared. It does not make any difference. The only difference is that the a here has a power of 32. So we are going to eliminate a. And what we're going to do, it means we're going to differentiate it. Since it has one constant, we are going to differentiate it once. So I'm going to have, if I differentiate y with respect to x, I will have the y dx. That's the first derivative of y to be equal to what? A. If I differentiate ax, I'm going to have a. If I differentiate a squared, I'm going to have 0. A squared is a constant. If you differentiate a constant, you get 0. So it means anywhere I found a in this equation, I'm going to substitute the y, the x. So substituting a, the y, the x for a in this original equation, I'm going to have y to be equal to x, the y, the x. That's what I have here, plus the y, the x all squared. So I would like to write my equation to be equal to 0. So I am going to have x, I'm going to have, if I bring this to this side, I'm going to have the y, the x all squared. If I keep this to this side, let me bring y to this side. So I'm going to have positive x, the y, the x minus y to be equal to what? 0. So you know, if I bring y to this side, it's going to be negative y. I'm going to have this, I'm going to have this negative y, which is going to be equal to 0. And I have been able to form the differential equation to that question. So that is the answer. Now, let us take the second one. I have y to be equal to a cos x plus b sin x. So I have a cos x plus b sin x. So here I have two constants. So it means I'm going to differentiate what? Twice. So if I differentiate y with respect to x, I'm going to have the y, the x to be equal to what? If I differentiate a cos x, I'm going to have negative a sin x. If I differentiate positive b sin x, I'm going to have positive b cos x. So I'm still going to differentiate here the second time. So I'm not going to stop here because I need to eliminate constant a and b. I don't like this constant. So if I differentiate the y dx, that's the second derivative of y, I'm going to have the squared y over the x squared to be equal to negative a sin x. If I find the derivative of this, I'm going to have negative a cos x. If I find the derivative of this, I'm going to have negative b sin x. You are going to observe that I have a cos x and b sin x here as my y. The only difference is the negative sign. So I'm going to factorize out the negative sign. So I'm going to have the squared y over the x squared to be equal to negative into bracket of a cos x plus b sin x. Now a cos x plus b sin x is our y. So we've been able to form this differential equation if I have the squared y over the x squared to be equal to what? Negative y. Now I would like my equation to be equated to 0. So I'm going to have the squared y all over the x squared plus y to be equal to 0. And that is the answer. So I've been able to do that. Now we are going to take the third question. Here we have the third question here. Question number 3 is y equals to a exponential to the power of 3x plus b exponential to the power of x. So again here, I have two constants here, so it means I'm going to differentiate this equation twice. So the first derivative of y here will give me the y dx to be equal to what? If I differentiate a exponential to the power of 3x, I'm going to have 3a exponential to the power of 3x r plus b exponential x, because the coefficient of x here is 1, so we're going to have this. Now I'm going to do something, because I'm seeing that after the differentiation, I'm having my y here. So what will I do? I'm going to expand 3a exponential 3x. So I'm going to have 3a exponential to the power of 3x is similar to a 2a exponential 3x plus a exponential 3x. I didn't change anything. 2a exponential to the power of 3x plus a exponential to the power of 3x is similar to 3 exponential to the power of 3x. So this is what I'm going to substitute for 3 exponential of 3x here. So it means that my dy dx is equal to 2a exponential 3x plus a exponential 3x, then plus my b exponential x. Now you can see that a exponential 3x plus b exponential x is same as my y. So it means my dy dx is equal to 2 exponential 3x plus y. So let me call this equation star. Now I will make a exponential to the power of 3x the sort of formula, because I don't like this constant a. So it means my a exponential to the power of 3x is similar to what? If I bring y to this side, it's going to be negative y. So I'm going to, if I divide by 2, I'm going to have the y over 2 dx minus y over 2. Now I will now go back to equation star. I'm going to differentiate equation star the second time, because I have two constants in the equation. So if I find the derivative of the y, the x of this equation star, I'm going to have d squared y over d squared x to be equal to, if I do this, I'm going to have 6a exponential to the power of 3x plus the y dx. Now I've been able to have this. Now don't forget that we said that a exponential to the power of 3x is similar to dy over 2 dx minus y over 2. So I'm going to substitute this for a exponential 3x. And you don't forget that this 6 is multiplying everything here, because this is a exponential 3x. So I'm going to multiply by 6 by the time I write this equation. So I'm going to have d squared y dx squared is going to be equal to 6 dy over 2 dx minus 6y over 2. Then I'll bring my dy dx plus the y dx. Now I can divide 2 by 2. I can divide this by 2 and divide this by 2. So I'm going to have d squared y dx squared to be equal to 3 dy dx minus 3y plus dy dx. So 3 dy dx plus dy dx is 4 dy dx. So I'm going to have d squared y over dx squared to be equal to 4 dy dx minus 3y. So I would like to equate everything to 0, so that we have d squared y over dx squared minus 4 dy dx plus 3y equals 0. And that is the answer. So we have been able to form that. So you can try this at your later time. So you have to form differential equation for y equals to a squared plus bx, and y equals to a exponential negative 4x plus b exponential to the negative power of 6x. So your answers for the first one is a squared, d squared y over dx squared minus 2x dy dx plus 2y equals to 0. And for the second one, you're going to have d squared y over dx squared plus 10 dy dx plus 24y equals to 0. Thank you. Now remember, the deal is that you must be happy, I must be happy, we must be happy. So remember to subscribe, comment, like and share. Thank you.